and we call this big data. For big data, there are 4 V's, basically featured with 4 V's. What are the 4 V's? Volume, data volume, huge volume, refers to the amount of data. We have huge volume. Velocities refers to the pace that data is created and stored, update velocity. Varieties, right? We have variety of data, which means there's a different form of data we can take. And finally, data veracity refers to the quality or whether data can be verified or trustworthiness of the data. We call it veracity. So 4 V's, okay, or the 4 features of big data. So let's talk about the big picture. We need to have a analytics mindset. Analytics mindset. This is a mental attitude, a way of thinking, or a frame of mind. So what is analytics mindset, basically? This is a way of thinking that centers on the correct use of data and analysis for decision making. So we have to think about how we're going to focus on data and how we're going to use data to make decisions. That's analytics mindset. According to Ernst & Young accounting firm, analytics mindset is the ability to do the following things. Right? With analytics mindset, we should be able to ask the right questions, extract, transform, and load relevant data, and apply appropriate techniques, data analytic techniques, and finally interpret and share the result with various stakeholders. So this is a big picture of mindset, and we're going to go through these things one by one. First, let's start how to ask the right question. How to ask a right question. So what is a good question? A good data analytic question is, it is a smart question. A good question is a smart question. So what is a smart question? A smart question means first, S, right? Must be specific. We need to be direct and focused on to produce a meaningful answer. So if you look at the interview of presidential candidate, right, those famous journalists, they ask very specific questions, yes or no. Okay, those are specific questions. Next, measurable, M, measurable. Okay, must be amenable to data analysis and thus input to answering questions must be measurable with data. Ask questions about temperature, right? It's measurable because we can measure the temperature. Okay, if we ask questions that cannot be measured with data, it's not a right question under the scheme of analytics mindset. It's not a question. Then achievable. It should be able to be answered, and the answer should cause a decision maker to take an action. Achievable. And it must be relevant, should relates to the objectives of the organization. Right? It will be relevant. And finally, it must be timely, must have a defined time horizon for answering. That's the SMART, which means it's a good data analytic question. So let's see some examples. For example, external auditor is visiting with several employees to understand the tone at the top of the organization. So the initial question is, how's the tone at the top? Auditor asks. Right? Obviously, this is not a good analytic question to ask. How can we improve these questions? First, if we want to make it more specific, what is the kind of question we should ask? I think about putting into the scenario. No, you're the auditor, right? And you want to understand the environment, basically the tone of the top of the organization's AI systems. So what kind of specific question you can ask? Right? Either it's a specific question, it's yes or no. Figure out any questions. Proceed with audit. Right? Can figure any questions. Yeah. Yeah, you can ask you, for example, why does your CEO advocate that he or she is going to, or she has a tone over the top, something like this, yes or no questions. Those are very specific questions to start with. Or make it more measurable. How to make it more measurable? Now you have to think about a question that can be measured. Like how frequent we receive training about this tone at top and things. Right? That's measurable. And then how to make these questions more timely. We have to define a time period. Yes. Yeah. So those are the questions that make it good questions for analytical, mindset. Right. So, and they will be very useful for being auditors. You have to ask very specific questions, basically. Right. That's talk about questions, right? Ask questions, and let's talk about extract, transform, and load relevant data. How do we do that? Extract, transform, load relevant data. This is a process of extracting, right, transforming, and loading data. Yeah. And this can be called the ETL process, right? Extracting, transforming, and loading. ETL process. ETL process. And this could be the most time-consuming part of the analytics mindset process, because Well, we have to do a lot of dirty work um, for ETL process. Fortunately, with advancement of the technology, especially with AI, now a lot of repetitive ETL processes can be fully automated now. And with AI, we can even make it more smarter for ETL process. And the AI can collect data and basically do all the ETL, mostly ETL process by AI, Well, if you're interested, well, the ETL processes is covered by the ACCT audit data standards. Okay, they have these audit data standards, which is telling us what are the standards for typical ETL process. But let's talk about some of the things. First, extracting data. Extracting data. Step one, we need to understand the data needs and the data availability. To understand data, we talk about several forms of data. Kind of small, right? First, we have structured data. Structured data. Structured data is data that is highly organized and fits into a fixed field. For example, we have financial data such as debt and the credit amount, right? Sales records, invoices, customer information. Well, we call it structured data. Structured data. On the other side, we have unstructured data. So this data has no uniform structures. Like we can have a data containing music, right, video, and the text, or even something else. We call it unstructured data. Obviously, we cannot put unstructured data into the balance, the Excel worksheet, right? There's no way to do that, or put into the, or be used directly. No, no way. And there's something in between, semi-structured data. We have structured, unstructured, and semi-structured. But we're gonna need structured data, right? For our analysis. Right? These are the several forms of data. And how data is stored. Data is stored in several ways. We can have a data warehouse. Right? This is the storage of structured data from many different sources in organization. So a data warehouse stored structured data. But the data warehouse may be too big, right? Too big. It's for the whole organizations. Sometimes we just need some of them. For example, I just need customer data. I just need sales data. So we talk about data mart. Data marts are smaller data repositories that hold structured data. So they are smaller, but more specific. We call it data marts. And finally, we have the data lake, right, which is bigger. Data lake is a collection of structured, semi-structured, and unstructured data stored in a single location. So we have a data warehouse, data marts, and a data lake. And metadata are data that describe other data, metadata. Basically, metadata shows what information there is database, metadata, or sometimes we call it directory information. So what's the problem with all these data? Problem is once we put everything right into the lake, we may not use it anymore because it's dark data. Means they will not be used, or maybe they're forgotten. They will be not be used. And then that's for the whole lake, right? And for smaller dark data, but again, it's messed things up. Not good. So these are the problem of the data. Therefore, it's very important to understand the structure of data, on a data dictionary and its metadata. We know where the data is and what it contains. So that's very important to avoid the dark data and the data swamp problem. But think about it with our own continuous hard disk. You throw everything, right? Every time you throw any kind of files into the hard disk, and after a few years, right, it becomes a data swamp because you don't know where you can find the file or information you want. So keep a good habit to record all the update into the data dictionary and build a metadata file to tell yourself or other users where's the data and what it contains. There's various ways to design our storage, at least 3, and we can have even more. So if you look at this, the first way to store data. So the circle means a structured, right, data, and these means unstructured. Look at this one. We throw structured data into the data warehouse first, and from the data warehouse, we're going to send various data into a subset of data. We call it data mart. Right, we know that. So all the structured data will be again sent to the data lake later. Together, also send unstructured data into the data lake. Well, this is the first way to design our data storage. How about the second one? Well, the second one is slightly different now. But we're going to store structured data into the data mart first. For example, we're going to store customer information into the customer data mart. We're going to store sales information into the sales data mart. And from the data mart, we aggregate all the information into the data warehouse. And again, into the data lake. And then unstructured data will be thrown into the data lake. Similar? A third way could be more efficient. If you look at the structured data now, simultaneously will be sent to data mart and the data warehouse. Right? And from there to the data lake, and unstructured data will be thrown to the lake. Right? One benefit of having this is, for example, this made a mistake, that's fine. Right? If this is correct, we can verify the information. All right, so these are the different designs for extracting and storing data. Any questions so far? Now that we'll talk about that, the design. Next is performing the extraction. We're going to extract the data. With permission, data is extracted into separate files or into a flat file. What is a flat file? A flat file might combine information from multiple different tables into a single table of information. Right, just to give you an easy example is, right, I have customer information, I have sales information, right, I have inventory information. So how about I combine all these together into one file I have, in which I have customer, sales, right, whatever inventory we sold to that customer, and that become a one table, and it's called a flat file. Flat file. Flat file may reduce the information, right, through aggregation because all of them are combined. However, a flat file may violate the design principle of a relational database, which we're going to talk about these later in the semester. So the flat file is going to make the table really big, cumbersome, so which we try to avoid. Think about it. If you have a table containing all the customer, sales, inventory information, how big the table will be, right? And kind of small. When we extract, we will have the information to determine which information is stored in each column, right? Easiest way is think about if we have an Excel worksheet and we try to put different information into different cells. How do we do that? If you ask computer to do that work, right? We need a delimiter or a text qualifier. Let me see if I can make it bigger. Should be. Right, the first example is pipe delimited. Right, if you look at right, the bar we call pipe delimited. So it's going to telling us, right, the cutoff line for different information. If you look at the first line, we have FN name, first name, last name. We use the pipe delimited to separate first name, last name, and performance scores. Okay, so when it's read right into separated data, you have right the four things read separately because of the pipe delimited. The same thing, if we use that pipe delimited, we can have these things. And the text qualifier, which is a quotation mark, text qualifier is telling us or telling the computer, right? Smiles a lot, enthusiastic, could improve technique is one data. But you can't see the usefulness from here, but it's very useful when we use comma delimited. When they are comma delimited, and then you're going to see the usefulness of the text qualifier, right? If it's a text comma delimited, no problem with the first name, last name, performance scores, and performance review. No problem with this, but we may have problem with this, right? Randy Armstrong is one data, 99 is data. However, if we do not use the quotation here or the text qualifier, right, then smiles a lot will be one term. Enthusiastic will be the second term. But we don't want that. So we use a quotation mark to make it a text qualifier, and this becomes one term. Okay, this is something about delimiter and the text qualifier. I think that's easy to understand. So here we have a question: which of the following characters would be best to use as a delimiter for financial data? So if we want to let computer read financial data, which one is best to use as a delimiter? A dollar sign, filter, a percentage sign, and a minus sign. Which one is the best? Okay, is the best choice to work as a delimiter for financial data?
Second what? Dollar sign. Separate. Dash.
Yeah, because in financial data, we're gonna see those signs. We can have minus, a deficit number, we can have percentage, we can have dollar sign. But we may not have this. This one is not typically used in financial data. So this can be the best choice among all these four to be used as a delimiter for financial data. So think about it. What kind of text qualifier we can use for financial data? Right, the quotation may not be the best use because we may have that in financial data. So you can design your own text qualifier. Then you're going to tell computers what is the text qualifier, and they're going to use that. Step 3. We're going to verify the extractions. Right, once the data are extracted, now I'm going to put into individual places. How to verify the extractions? Typically, we can do batch processing controls. For example, we can take total for every, for example, 10 financial statements together. We can do a total, the batch processing controls. We can compare smaller data extract with a full data extract or create new data dictionaries. This part is very difficult. Typically, we have to verify by, in addition to all these technologies, we have to verify the human beings, not easy. After we extract data, we need to transform data. The 4 steps in the data transformation process. First, we need to understand the data and the desired outcome. So what do we need, right? standardize, structure, and clean the data, which is time consuming, and validate data quality and verify data meets data requirements, and finally, document the transformation process. What is high quality data? High quality data means first, it's accurate. Examples of violation of this attribute. The sales occurred at December 27th, but it's recorded as occurring the following year, right? Obviously, it's not accurate, right? Must be complete. Financial statement containing 12 months' performance, right? It only contains 3 quarters. That's incomplete, for sure. Why it must be consistent? It cannot switch denomination all the time. For example, financial statement, this year I'm using $1 million denomination, and next year I'm using thousands. That's inconsistent. And the data will be low quality. Typically, they're not that useful, which may cause big problems. I think that one of the, I don't remember which accident, but there was an accident in the shuttles, space shuttles, right? Because the problem is caused by inconsistent data, because they had a data which is measured by miles, and the other data is measured by kilometers, and they mix those two data together. They're not consistent, which caused the accident. Right? It must be timely, we know that, and be valid. Data measure what it intended to measure. For example, there are only 7 unique job positions, okay? And there are 9 different positions recorded. Obviously, 2 of them are not valid. All right, so these are the attributes to make a high quality data. Data structuring. Data structuring is a process of changing the organization and the relationship among data fields to prepare the data for analysis. So to make it easy to understand, right? Structurings, we mean aggregating the data. For example, I extract data, I have year, I have months, I have day. If I aggregate together, combine them together, become a date, right? That's aggregating. And joining different data together or pivoting the data. Pivoting the data means changing the way we present. We can switch the column, right? Make a column into the row and row into the column, pivoting the data. Data standardization. Well, this is a process of standardizing the structure and meaning of each data element so it can be analyzed, be used in decision making. That's easy to understand. Data parsing, which is separating data from a single field into multiple field. Right? We use a lot data parsing, like we have a date, but I just need a year information. So I'm gonna separate year, month, and day. So I have the year information. That's called data parsing. And the opposite way is data concatenations, right? It's combining data from two or more fields into a single data. They can put the year, month, and day together into the date information. All right. Cryptic data values. These are data items that have no meaning without understanding the coding schemes. For example, the data containing 1, 2, 3, right? It's meaningless unless we have the coding scheme. 1 means Toyota, 2 means Ford, 3 means GM. But looking at 1, 2, 3, okay, they're meaningless, but we need to understand the coding schemes. Sometimes the field contains only two different responses, yes or no. But typically it's 0 or 1. And this field is called dummy variables or digital variables. Okay, on and off, yes or no. And they are not considered cryptic data. Dummy variables are not cryptic data. So what are misfielded data? They are data values. Data values are correct, but correctly formatted, but they're not listed in the correct field. It's basically into the wrong field, right? The formatting relates to ensuring that the same type of data is presented in the same way. That's easy to understand. And then data consistency is a principle that every value in the field should be stored in the same way. It's not difficult. And we also need to clean the data. Means we need to update the data, make them to be consistent, accurate, and complete. So dirty data means data is inconsistent, inaccurate, or incomplete. Right? To be useful, dirty data must be clean. What are the typical things we need to do? Duplication. Right? Sometimes we have to remove two or more records contain identical information. Right? We need to remove the duplication. And data filtering is a process of removing records or field of information from a data source. We call this data filtering. And data imputation, this is the process of replacing a null or missing value with substituted value. Okay, this is easy. This is interesting to talk about data imputation. For example, right, we can collect population information. For example, for Katy, population information, we have 2000. We have a population number, right? And then 2004, we have another population number. 2008, we have another number. However, we don't have the number for 2001, 2, 3, 5, 6, 7. We don't have that. Okay? And then now. But if I remove the now, I can remove the now, but I'm going to lose those years information for other purposes. So what we can do is, right, these are the information we have. Just for example, right, this is a Just for example, I have 10, 20, and 30. See, from the 10, 20, 30, we can see the growth of population is very even. It's growing, right? If we assume that the speed of growth will be constant, then we can calculate, right, what is the population for 2001, 2002, and 2003? How do we do that? So that's I need the growth to be 10. 10 is going to divide it by 1, 2, 3, 4. So this will be 12.5, 15. And this will be, right? So 2001, the population is 12.5. 2002, that's 15. 2003, 17.5. And then 2004, that's 20. That makes it logical. We call this process imputation. Okay, this is how we deal with a null or missing value, typically. And sometimes we just miss one number in between 1 years. For example, we missed 2001 number, but we have 2000 and 2002. So that's easy. I just take the average between 2000 and 2002, and I can have the 2001 number imputed. However, this only works for numerical data, but if it's character data, there's no way to do the imputation. All right, any questions? Data contradiction errors are errors that exist when the same entity is described in two conflicting ways. For example, the phone number is mentioned in two different places. They're telling us different phone numbers. Obviously, it's a contradiction error. And the contradiction error must be investigated, okay, and resolved appropriately. And sometimes we have data threshold violations, right? For example, human beings' age, if you notice, a voter's age is based on the records is 150 years old. Obviously, that's threshold violations, right? That's a data error. Can't be a 150-year-old voter. No. But this is something more. Violated attribute dependencies. These are the errors that occur when a secondary attribute in a row of data does not match the primary attribute. Right, we're describing human beings. Later, we have another attribute that is showing could be it's not describing a human beings. So obviously that's attribute dependency error, right? Data entry errors are all types of errors that come from inputting data incorrectly. Right, when we input data, usually we're going to have input data errors. That's human beings that introduce the error, right, into the computer systems. And finally, we have the data validations. Right, once it's cleaned, also need to be verified. We need data validations. Data validation is a process of analyzing data to make sure that the data has been they are high quality data, for example, for sure. And this could be both a formal and informal process. For example, the techniques used to validate data can be thought of as a continuing from single to complex. So what are the typical techniques we use? Visual inspection. Right? This is a very informal, but if you don't have too much data, visual inspection is the quickest way to have the data validation. Sometimes we can do basic statistical tests. If we have a lot of, for example, numerical data, we can do some basic statistical test. For example, I can calculate what is the average, right? What is the range of the data? From there, we can easily notice their abnormal values or outliers that could be error, right? For example, you have the age columns, you have millions of age. So we can do the calculate the range of these columns. The typical range will be from 1 to 100 something at most. If we give you a range negative something to 300, obviously those negative and those above 100 could be errors for age data. We can do an audit. We can audit a sample of the data. Right, this could be the best techniques for assuring the data quality. Right, if we have 1,000 piece of line of data, could be time consuming, but I can check 100 lines randomly. If I check 100 lines randomly, and I find 5 mistakes, right? My error percentage will be 5%. If that's acceptable, right? That's fine. If your standard is 1%, you allow 1% error, then we have to go through the whole database again to reduce error to 1%. That's an audit sample. The key is to select a subsample randomly. Okay, select subsample randomly. That's the key. We have advanced testing techniques, but that require a deeper understanding of the content of the data. We're not going to talk about that. Right, and we're going to load the data for sure. Once they're cleaned, right, verified, we're going to load the data. The transform data must be stored in format and structure acceptable to the receiving software. Once the data is successfully loaded into the new program, it is important to update or create a new data dictionary. And sometimes for the same data, we need to load them into different systems. So we have to make sure that they can be successfully loaded. Right, this is something about ETL. Let's move to the next stage. We're going to do data analytics. Now, once we have the data, we're going to start our analysis. So what are the types of data analytics we have? After preparing the data, we're going to apply appropriate data analytic techniques. What are these techniques? We have descriptive, diagnostic, predictive, and prescriptive. What are these things talking about? Descriptive analysis. Basically, they're going to telling us what happened. what happened. That's from descriptive analysis. The diagnostic analysis is going to tell us what did this happen, reason, right? And predictive analysis is going to tell us what is likely to happen in the future. And then the prescriptive analysis is going to tell us what should be done next. The 4 levels of data analytics. So let's talk about the basic level, the descriptive analysis. Descriptive analytics is described, right? Information, the basic information from examining data to understand the past. This is something about past. What happened? What happened? This is often used as exploratory data analysis techniques. Right, for example, I can analyze the previous month's temperature. Right, that's a typical descriptive analytics. What kind of attributes of data we often explore? Right, often we explore central tendency. A central tendency means, right, we're gonna look at mean, median, or mode of the data. We're gonna explore the spread, including the range and the standard deviation. And I'm sure you have learned these terms from the statistic classes, or not? We need to look at distribution and the correlations. Typically, they will show in a visualization or this, like this. The top left, that's a distribution. That distribution is skewed, have a long tail, right? Long right tail. It's skewed. It's not normally distributed anyway. And the second top right graph, it shows it's a normal distribution. Right? We have a mean, median, mode as the same number. For normal distribution, mean, median, mode will be the same one. Sometimes we're gonna, by the normal distribution, we have a unimodel. We can have data that distributed with bimodal, two hills, right? Or the multimodal. And this graph shows correlations. This could be the weight and the height for children's, they're correlated typically. The higher the kid, the heavier the kid will be, right? They're positively correlated. So these are the attributes we often look at. That's a descriptive analytics. Going to tell us what happened. Well, the next we're going to move to the next level is, why did this happen? Why did this happen? We can have informal analysis and formal analysis. So let's talk about informal analysis. Informal diagnostic analysis often use logic and a basic test to explain why something happened. Right, for example, a company observes that the overall gross margin fell, right, for the last month. So they must investigate or examine something Now they might examine the mix of products sold during the last month. Do we sell more low margin products last month, causing our gross margin fell? That's possible. So we're going to do those kind of things. And these are informal analysis. They use a logic and a basic test to find the answer. But we want to know, what is the formal analysis we do? Okay, and these formal analysis will be used for scientific research or investigation often. Formal analysis build of confirmatory data analysis tests, which is also known as hypothesis testing. Hypothesis testing. Right? Hypothesis testing typically involves the following 4 steps. First, we need to set up a null and alternative hypothesis. A hypothesis is a testable test statement. For example, if temperature increases, ice cream sales increases, right? This is a testable statement. We call this hypothesis. A hypothesis should be thought of as 2 statements. A null statement, which means there's no relationship. For example, the null statement for the temperature and ice cream, the ice cream sales has nothing to do with temperature increases. The ice cream sales increase has no relationship with temperature increases. This is a null hypothesis, which means there's no relationship between temperature and ice cream sales. We could have an alternative hypothesis, right? And these things are now related. So a null hypothesis could be, alternative hypothesis could be, when temperature increases, ice cream sales increase, right? This is an alternative. Or ice cream sale decrease is another alternative. That's alternative hypothesis, which means they are related in a positive or negative way. Right, so when we test the null hypothesis, we can have 2 errors. 2 errors are possible. When the null hypothesis is actually correct. Right? If null hypothesis is actually correct, the data finds supporting evidence, the data finds that null hypothesis is also true. That we can prove the null hypothesis is correct, right? If the null hypothesis is actually correct, then the data say the null hypothesis is false. We're going to commit type 1 error, because it's type 1 error. If the null hypothesis is actually false, and the data finds it's true, then we're going to commit a type 2 error. So these are the famous type 1 error and type 2 error. Will be very useful for hypothesis testing. How do we test? We're going to test the null hypothesis by setting up a level of significance for refuting the null hypothesis. We can always refute the null hypothesis. It's untrue, right? And this level of significance is the probability of accepting a type 1 error. For example, I'm going to set a 5% level of significance. Okay, this means I can accept 5% of type 1 errors, 5% of type 1 errors, okay, or even below will be fine for me. So for 5% of the chance, even if the null hypothesis is true, and I reject it from the data, okay, that's fine. 4% is better, 2% is even better, right? However, if I find 10%, that's not acceptable. 10% means I cannot reject the null hypothesis. Okay, this is typically how we use the level of significance in hypothesis testing. For example, ice cream and temperature stuff. We collect a sample of data, okay, and we build a model. Right? We find ice cream sales equals 10 plus 5 multiple temperature minus 2 multiple stock market performance. This is the model we want to test. Right? The data return a probability level of 0.04% on the coefficient of temperature and 23% on the coefficient of stock market performance. So I'm looking at those two coefficients. And for the phi, coefficient phi, which is coefficient on temperature, right? The probability level is 4%. 4%. And this is below my chosen significance level 5%. Meaning, right, it's lower than the significance level 5%. Means we should reject the null hypothesis. We should reject null hypothesis that ice cream sales and the temperature have no relationship. This null hypothesis should be rejected. In other words, they do have relationship, and this relationship is expressed by this coefficient of phi. So when the temperature rises by 1 degree, right, my sales will increase 5 times that, or 50. This is what the data tells us. However, for the coefficient on the stock market performance, the -2, okay, the probability level is 23%. That's well above the acceptable 5% significance level, meaning we should not reject the null hypothesis between the ice cream sale and the stock market performance. In other words, they are not significantly related. Okay, we fail to reject the null hypothesis. Any questions? It's a very important hypothesis testing procedures. It's very important that for all these kind of tests, we can only test whether we can reject a null hypothesis. We can do that. Right? We can prove that they have no relationship is false. It's very difficult for us to prove that whether they have relationship is true. I can test if whether they are not related. I can reject this hypothesis, but I can never prove they are related. This statement is true. This is for scientific scientific test. This is a very important concept. Any question? It's diagnostic. Move to the next level, the predictive. Predictive analytics. These are the information that results from analysis that focus on predicting the future. Right? Now we know the relationship between ice cream and their temperatures. So I can predict my next month's ice cream sales if I have information about the next month's temperature. Right? That's possible. That's predictive analytics. And with machine learning, okay, it's going to allow the computer systems to improve and update prediction models on their own. Right? A typical usage of this is the weather channel is going to predict the move paths of Earth. Okay, it's based on the various models they have. Okay, they have a big database with all the temperature, right? Ocean movement, whatever the information they have. They can use all this information to predict where the hurricane is moving towards. Okay, the past. Of course, it's not going to be 100% accurate, but with today's technology, you can see they are pretty accurate. Finally, that's prescriptive analytics. Right? And they're going to provide recommendations of what we should do, what should happen, what we should do. Prescriptive analytics, right? One example is, for example, the UPS designed real-time prescriptive analytic solutions for the drivers to optimize their delivery routes. Right? Traditionally, the UPS driver can follow the fixed route to deliver all the packages, but sometimes it's inefficient because you don't have to go through that way because you have nothing to deliver of that blocks. So with a model, right, it's going to calculate the best route for the UPS drivers to go, and it's going to tell the driver what to do. That's prescriptive analytics. Prescriptive analytics. Now we have a lot of auto trading systems, right? Financial market auto trading systems. Those systems can trade by itself. It's based on this prescriptive analytics. Going to calculate what's the best sell or buy up, right? Decisions to make by the system itself. This can see as we move up, it becomes more complex, right? And the value is also will be higher. So the prescriptive analytics is most complex analytics, but also the most value-added analytics for organizations. Of course, the most difficult one. Any questions so far? Common problems with data analytics. What are the common problems we have? Data overfitting. When a model is designed to fit training data very well, but does not predict well when applied to other data sets. And that's a typical problems we have, right? And with this sample of data, we can have a really nice model to do everything we want. It's going to give us desired results. However, if we apply the model using another sample of data, then it may not work. It may not work. Extrapolation beyond the range of data is a process of estimating a value that is beyond the data used to create model. Right? Typically, we use ordinary data to build models. Right? However, sometimes there are extreme scenarios in which we have never seen before, like the COVID, for sure, it's out of the traditional model predictions, right? Because we never had those extreme environment before. So in the COVID cases, it's beyond the range of data that is used, right? For sure. So a lot of model will fail during the COVID time because we never had data before. Or failing to consider the variations inherent in a model. All right, so these are the typical problems with data analytics. So what are the data analytics skills accountants are expected to have? So we have a summary of the data analytics techniques that you should have, but let's just take a look at you can review by yourself, right? You know how to get ratio, sorting, aggregation, no problem, right? Trends, comparisons, forecasting, descriptive statistics, right? Querying. Must Excel, right? Access, we're going to talk about access, right? Visualization skills. We're going to talk about visualization briefly. Those are the things that accountants should master. So what are the things that we should have a good knowledge with? Working knowledge, cluster analysis, right? Inferential statistics. So for example, in the hypothesis testing, we're going to use t-statistic and p-values, so you know what they mean, right? And correlation analysis and regressions. So for database, we need how to use SQL. We're going to talk about that and other things. That's a career path specific, for example, forensic, right, accountings. And other things that we should be aware of, but not necessary to master. Like the programming languages. What kind of programming languages you're familiar with? Perl, Python, Java, right? Or the statistics packages, right? SAS, SPSS, right? Or the database tools, SAP, Oracle. So we have a chance to learn a little bit about SAP, but these are the things we should be aware of. Interpreting results. interpreting results can be really complicated. Even if we have the models, right? We have the data, and interpreting can still be difficult. Right? One common way people interpret results incorrectly is because they get confused about correlation and causation. Correlations means the two things happen at the same time. There's a causation. Causation tells what the occurrence of one thing will cause the occurrence of the second thing. That's causation. They are two different things, but in statistics, look like the same. Well, in the previous example, the relationship between temperature and ice cream, and we show they are correlated, right? The two, when temperature goes up, the ice cream sales goes up. Based on our understanding logic, right? They have a causation, and the temperature increases is going to increase ice cream sales. Okay, and we know that it's logical. But many times these not difficult to are not easy to differentiate. Other examples of correlation, but there's no causation. But just for example, the stock market performance and and the uh, and the voting trend. Well, these two things can be correlated. For example, the stock market perform better, and one candidate is going to lead another candidate in the voting. Okay. However, it's very difficult to say which caused which occurred first and which occur later. The causation is unclear. Think about it. What? I say that it's because the stock market pushes higher and one candidate is going to lead another candidate. It's very difficult to show. Or it could be vice versa. Because one candidate leads another candidate, then the stock market goes higher. So I can only say that they are correlated, but whether they have a causation, no. It's not easy to say. So we have to differentiate the correlation and causation clearly. And the second mistake is related to psychological issues. Psychology research shows evidence there are some systematic biases, right, in the way people interpret results. Always biased toward interpreting results toward the way we want it. And it's going to cause bias. It's going to cause bias for sure. sharing results. And finally, we're going to share the results to data storytelling. This is the process of translating often complex data analysis into more easy to understand terms to enable better decision making. It's very important. Right? Many times only the expert scientist is going to find results, but they need to translate these findings into easy to understand terms so people understand. To tell a successful data story, right, you need to remember the questions that initiated the analytical process. What caused you to do all these kind of work? That you have initial questions, and we're going to answer that questions. We need to consider the audience, right? The way we tell the story to our group of peer expertise or to the public will be different. Consider the audience. We're telling a story, right, to the public in a TV show, okay? Make it easy to understand. But if you're presenting the results to at an academic conference or scientific conference, it's another story. And use data visualization, okay, which is very important. No matter we are presenting to expert or to public audience, data visualization is always important. So let's talk about data visualization. Data visualization is the use of graphical representation of data to convey meaningful information. Data can be presented in many different ways, right? We can have static graphs, tables, videos, static or dynamic models, eccentric. Depends on the purpose of visualization. We use different ways. So what are the purpose? Right? The purpose is to compare things. Quickly is bar chart or the bullet chart to compare these different things. If the purpose is to show correlations, right? We can use the scatter plot or the heat map to show correlations. But the scatter plotter is going to show the correlation between the horizontal and vertical lines. And if you look at a scatter plot, it shows it's obvious that these two things are right positively correlated. And in the heat map, the more darker cells is going to tell us they're more correlated. So this and this, they're closely correlated together with this. Right? It's a heat maps. Heat maps. If the purpose is to show distribution, then the histogram and box plot is best choice. Remember this box plot. I just trained my daughter for her test. That's a middle school test for box plot. You remember box plot? What does it mean? What does the box mean? Huh? Box shows, if I remember correctly, box shows the second and third quarter. Right? This is a range. Largest, smallest. This is the middle second quarters. Right? And I believe this is the median. That's a box plot. And also histogram is also can do the same thing. We can show the median mode, right? Means in the histogram. But if the purpose is to show trend, then the line chart and area chart are the best choice. And finally, if the purpose is to show part to whole comparisons, then the pie chart and the tree map could be the best choice. Depends on the purpose. Okay, and this is very useful in the future, right? You know what's a basic visualization you should use. Designing high quality visualization is very important. So what are the principles we have to design high quality visualizations? First, simplification. Right? We're going to make visualization easy to interpret and understand. That's key, to simplify. We also need to emphasize the story we want to tell. Okay, we want to ensure that the most important message is easily identifiable. And ethical presentations. Okay, we need to avoid intentional or unintentional use of deceptive practices that can alter the user's understanding of the data being presented. That's about ethical presentation. So we're going to go through these with some examples very soon. And the visualization company Tableau provides daily good visualization that users upload. Let me see if I can open this link. Here, let me see. Should be okay. Anyway, we can actually search Tableau provide daily visualizations. It's going to give us some really good examples of interesting visualization presentation that users upload. Yes, it's called a Viz of the Day. Yes, that's what I'm talking about. All right, the Viz of the Day, as their users uploaded the visualization they think are good, high quality visualizations. So they upload it so you can take a look at these things, how they present stuff using high quality visualizations. Right, which might be useful for your future presentations. You can take a look at their design style. Right, if you have time, you can take a look at it. Thousands of cool visualization stuff. Right. All right, so let's talk about a few things. Right, so let's take a look at upper visualization. Compare the upper one with the bottom one. Which one looks better for you? Which one is easy to understand from your perspective?
The bottom one.
Yes, should be bottom one.
The numbers aren't
Okay.
there.
Okay. So let's introduce the idea of distance. So in order for the top one first, in order to understand what now you look at the three part, okay, and you get an idea. This is high, this is lower. But first, you need to identify what they're talking about. So you look at this graph. Look at here, right? The three different colors shows three departments. So in order to connect the color to the department, you have to take a quite long distance to collect both information. Yeah, this is what means distance. Distance is not a good things to understand. So the bottom directly gonna put the department, right? It's closer to those bars. Now it's easier to understand. In addition, right, you mentioned, right, the numbers. Now closer because and the top visualization you have to measure, right? If you may have the numbers in the y-axis, but it takes time to measure another distance we don't want to reduce. So now what the numbers are added. Right, so we reduce the distance and improve the visualization, okay, or simplify the visualization by reducing distance. This is what it means. Obviously, it's not bad, but this is better. You can also use color to emphasize, to highlight, right, the one we want to focus. So what did you see? It's annual income by education and department. Right, we have no college education, associate, bachelor, and master degrees, and their income. And by department. Which one is better? Right, we have 1, 2, 3, three different visualization.
Did you say which one was better? I'm sorry.
Yes, which visualization?
I like 3 because I feel like that showed immediately like the distinction between the associate's degree, bachelor's degree, master's. but definitely not 2.
Okay, yeah, definitely not 2. And if you compare 1 and 3,
Okay.
depends on the purpose, depends on
Yes.
which one we want to highlight. For
Right.
example, I'm presenting these results to the home electronics department only. My audience is home electronic department. Which visualization you're going to adopt?
The first one,
Yes,
because the
right? That's the
specialization in
first
that.
one.
Yeah.
Because the home electronics is highlighted, okay? And it's very obvious to show the result, present results to this audience. What it tells us, right? Interesting finding, right? Right? With no college, but work for home electronics, right? Your income will be the highest. That's possible. People are street smart, right? So you can sell more home electronics. So yeah, so this is of course, we have various ways to highlight, depends on the audience or the purpose of the presentation, right? Looks like 1 and 3 could be the choice, but if our audience is, we want to highlight home electronics, then the first visualization is the best among the 3 because it has been highlighted. We can have depictions of techniques to increase visual weight, right? Going to give certain things more weight. How do we do that? We can use color, right? Can show more saturation, right? More saturation means more weight. Visually, it's more. We have more weight, right? On the left-hand side. Or we can increase the contrast to show weight, right? We can make things show complexity to show the weight, or density to show the weight. And obviously, the larger size, right, the greater the weight will be. So these are the techniques we often use, okay, to show weight. Examples of unethical, right, presentation. What did you see here? First, we are showing the job satisfaction between Jason and Annette. What's the problem with this visual? What's the problem with this one? Right, looks like Anita is much worse than Jason, but in fact, the difference is only 0.1. So this could be more appropriate to present, to compare Jason and Annette. How about this one?
It's really exaggerated.
Yeah, it looks like Jason's much better than Annette, although, right? If you look at the numbers, they're very close, but the Jason's bar is much larger than Annette's bar, so it's an ethical presentation for sure. You also have incomplete visualization presentation is also unethical, right? This shows a daily closing price is Dow Jones Industry Average. Look at the whole picture, right? It's almost even, could be a small increase. But if we present, right, section of those, you see we have different conclusions. It's a rise, right? Small rise and decrease. It's not going to give us whole picture of what have happened for the Dow Jones. industry average for the past. And finally, automation. Automation is application of machines to automatically perform tasks that used to be performed by human beings. Now it has been taken over by AI for sure. Robotic process automations is computer software that can be programmed to automatically perform tasks across applications, just as human workers do. One examples of automations is we know not too long ago, people studied the DNA. Okay, DNA is a chain of stuff. I'm not familiar with that. A chain of stuff. There's a lot of millions and millions of combinations to generate different results. So in the old days, but not long ago, a decade ago, research in this area will be very difficult. We do experiment by human beings try to create different combinations for DNA, to study DNA. Now, the AI has taken over the work. In AIs, we build models which can have thousands of experiment within the programs. It's going to simulate human experiment. The AI is going to create or study a different combination of DNA chains, and it's going to generate. It has been generating thousands of results that might take decades for human beings to find. So it has created big breakthrough in that research areas because of the automation, basically data analytics, taken by AI.